Okay, hello everyone. Guys, hopefully you just went to the Zoom meeting at the start of class and now you're watching the video. All right, today, and it's okay if you watch it before, guys, or if you're watching it later. It's all right. You can always stop the video if you want, rewind it, watch it again. All right, it kind of has all the answers for you in this top video, the one you're watching right now. Transformations of absolute value functions. That's the title of today's lesson, and you're going to need that for the notes assignment, okay? Guys, today's objective is to transform the graph of the absolute value function. This is the absolute value function right here. It's shaped like a V, okay? The essential question, and again, you're going to need to know this for the notes assignment. What do changes to the absolute value parent function do to its graph? All right, the parent function is this one right here. All right, and we'll talk about that in a minute. But we can change it around. All right, there's a bunch of vocabulary words as normal. That's kind of how we start. Let me try to get my face out of the way here. All right. Guys, maybe I'll move this over a little bit. Guys, the absolute value function makes every number positive. It's the positive distance from 0 to a number line, or from 0 on a number line. Guys, it's always positive, all right? You've seen it before. The absolute value makes every number positive, okay? It's a distance, so it's always positive. All right, absolute value measures magnitude. It measures how much or how far. It doesn't care which direction, okay? It measures magnitude, not direction, okay? As a parent function, it's the simplest function of a family of functions, all right? And it preserves the shape of the whole family. The absolute value parent function, here's the equation down here, y equals the absolute value of x. Okay, and it's shaped like this. Again, shaped like a V. The vertex is right here at 0, 0, at the origin. Right, and this right side has a slope of 1. You see that? It goes up 1 over 1, up 1 over 1, up 1 over 1, okay? Because there's nothing in front of here. I mean, there's a 1 actually in front of here, okay? It's implied. Again, we just talked about the vertex. I'll move my face down here again. Guys, the vertex is the maximum or minimum point of the function. It's where it changes direction, okay? It's that point. If this was a polygon, we'd call it the corner where the two sides intersect. Okay, in geometry, that's what a vertex is. But in algebra, against the max or min point, it's where the slope changes direction from positive to negative. Guys, a translation, all right? It's a shift of the graph horizontally, vertically, or both. Sometimes we call it a slide. Again, this blue dotted line is the parent function. And we could slide it around. It doesn't have to stay always where the vertex is at the origin. We can move the vertex around. Okay, you see how it keeps the same shape? All right, we're just moving it. We're sliding it somewhere else. Okay, and we'll learn about these formulas here in a minute. See, this one, you notice x plus 3 moves it to the left 3. Whereas x minus 2 right here moves it to the right 2. On the outside here, the minus 3 moves it down 3. See, this one has nothing out here, so it's kind of like plus 0. So it just stays right here, okay? Because we also have a reflection, right? It's when the graph is flipped upside down, all right? It's the graph of the same shape and size. It's just pointing in the opposite direction. You can see what happened here. We just put a negative in front here. All right, that made the slope of the right side coming down here -1. All right, the slope is -1. Down 1 over 1. Down 1 over 1. See that? It's -1. All right. Y'all, this particular part is a little bit hard to get. You might not get it right away. I'm trying to move myself around here so I can get out of the way. How about right there? Okay, so when we expand the absolute value equation, it looks like this. And you're going to need to know this. This is maybe the first time you've seen it, and we're going to work with this a while. Right? It's okay if you don't understand it right away. Okay? I just want to explain to you what each of these does. Remember, the parent function just said y equals x, the absolute value of x. Well, we've done a couple things. First, inside the absolute value sign, we put this -h in there. And outside the absolute value, we added a k. And in front of here, we put an a. You remember, a is kind of like the slope. All right? We talked a little about this before. The h moves the graph left and right along the x-axis. But because this is a negative, you see that right there in the formula? It's a negative. It's kind of the opposite of what you think. In other words, if this says x -2, you move it to the right 2. If it says x +2, you move it to the left 2. All right? Outside here is the k. K moves it up and down. All right? When it's +2, when the k outside here, +2 outside here, that means you move it up 2. It's exactly like it reads. Plus means move it up. Minus means move it down. Okay? It's different inside the absolute value sign because you're right next to the x. Okay? It's kind of the opposite inside here because this is a minus sign. All right, anyway, the a on the outside here, it makes the graph wider or thinner or upside down. It's kind of like the slope. If a is negative, it's upside down. Okay? If a is greater than 1, it's thinner. It goes up faster. So it's thinner. If a is less than 1, like a is a half, it's wider. Wider, because it goes up slower. Okay? And we'll look at some examples. Let's look at one right now. All right, guys, let's say you get an equation that says y equals this right here. This is the function. The blue 2 in the front, right here, that makes the graph narrower. It has a slope of 2. This right side has a slope of 2, and the left side just mirrors it. So if you start the vertex again, you go up 2 over 1, up 2 over 1. Remember this 3 right here? Because this says -3, you move to the right. So you start at 0, I move to the right. 1, 2, 3. This -2 on the outside means you move it down 2. Down 1, 2. And that's where the vertex is. And the vertex, the x is the opposite of what you see right there. That says -3. That means it's at +3. But it is exactly like it reads on the outside for the y. If it says -2, then the vertex is at -2. The y coordinate is -2. Okay? Keep that in mind. It's one thing that students get mixed up a lot, and so did I. And I still do sometimes, okay? Let's look at another example. All right, here's our function. Y equals this right here. First, there's a negative in front of here. Negative. Now that just means -1. So our slope on the right side is -1. Down 1 over 1, down 1 over 1, okay? And I flip the graph upside down. It's negative. +2 again moves the graph 2 units to the left. 2 units starting at the origin, 2 units to the left. The +3 on the outside moves the vertex 1, 2, 3 units up. And there's the vertex right there, okay? Starting from the origin, back 2, up 3. And again, it's the vertex is at the point that is the opposite of what's by the x and exactly what's on the outside. The hanger, that's the y. Because if you think, if we subtracted 3 and put it over on this side, it would be y minus 3 on this side. All right? Guys, that's it for this video. Right now, please fill out today's notes assignment and complete the summary assessment. That's in the green folder. As the answers are pretty much right here. I just gave them to you. Look at this video again. And use the copy of the PowerPoint slideshow I just went through. It's in this green folder. All right, then prepare for the next Zoom meeting. Don't forget to come to the next Zoom meeting. You have to go there. We'll go over the vocabulary assignment together. All right, which is in the orange folder. So come to the next Zoom meeting. And these are today's vocabulary words. They're right here. There's 5 of them. Make sure you get them because you need them for the notes assignment. Again, they're always on the last slide in the top green folder. Okay? All right, guys, that's it. Thanks.